The Engineering Medal for Research and Development recognizes professional engineers using new knowledge in developing useful, novel applications, or advancing engineering knowledge or applied science, or discovering or extending any of the engineering or natural sciences. The first recipient of the Engineering Medal for Research and Development is Gregory Kopp.
My name is Greg Kopp. I'm a professor of civil environmental engineering here at Western University. I hold the Impact WX chair in severe storms engineering. I work on mitigating the effects of severe storms on the built environment, primarily on buildings. The most vulnerable part of the building isn't the structural system, it's usually the window glass and the doors which break. They let water in and cause a lot of damage, and so we're working on mitigating that. And then the other thing we do is following storms, we go and look at the damage. And it's really fascinating what you see. Like after a tornado goes through a town, it looks like utter chaos. But after you've been to a few of them, you start seeing the patterns and you start seeing the same failures over and over again. And so it gives me really a lot of satisfaction is being able to fix those problems. And as an engineer, what we bring to it is that we find solutions that are inexpensive, but also meet the needs that we have in society. We actually now, through the Northern Tornadoes Project, which we formed here at Western, we do the damage surveys and identify every tornado in the country. Many of them occur in the forests, and we go and we put drones and use satellites to study those. But when they're in cities, in towns, when farms are hit, we send teams out to study the damage and document it. One of the interesting things about tornadoes, when you hear about a wind speed of this tornado had 200 miles an hour, no one measured that. It was all based from a forensic analysis of what happened in the storm. And so that's part of what we're doing. Well, I was born in Vancouver, but I grew up in Winnipeg, so I consider Winnipeg my home. My undergraduate degree was University of Manitoba in mechanical engineering. Then I went to McMaster for my master's degree, and then University of Toronto for a PhD. Spent 2 years in Spain doing a postdoc. That was in a chemical engineering department, but I was doing wind tunnel testing, studying chemical mixing. And then after that, we moved to Western, where I got the job in civil engineering. So I've been in 3 different engineering disciplines in my career, which has been really useful in the kind of work that I do in wind engineering, where there's a lot of fluid mechanics, mechanical engineering concepts, but I'm working on structures and structural design. We've been doing wind engineering at Western since 1965, before I was born. This wind tunnel that we're sitting in was built in 1983. And it's still state-of-the-art, and we use it for determining wind loads on buildings, on bridges and other structures, and lots of the most iconic structures in the world were tested here. And more recently we've been using it again to study houses. We test high-rise buildings. One of the big issues with the design of high-rise buildings is the comfort of the occupants. So the buildings are strong, but they sway. And if they sway too much, you start to feel uncomfortable. And so one of the things we do is work on getting those loads so that people are comfortable in the buildings. For a large stadium roof or a large span roof structure of any kind, you don't want it to move too much. You don't want it to break, obviously. You don't want it to collapse. But that's also part of what you need to study. We do other kinds of testing for environmental things, like measuring dispersion of contaminants from a smokestack. Also, with the wind environment around buildings, high-rise buildings bring high-speed wind down to the ground level. And this can be dangerous. So if you're coming into the basement of a high-rise building or the first floor, and you open the door and a gust of wind comes and it blows you off your feet, that's the kind of risk that's there. And so getting an understanding of those wind speeds to help design mitigation measures so that it's both safe and also comfortable around these buildings. Often they're hotels, and so they have swimming pools and lounge areas. If it's windy all the time, no one will want to sit there. So we work on mitigation measures for those kind of things. We have a lot more technology now for the wind tunnel, especially with things like measuring wind speeds. We use different technologies, laser-based methods with cameras and imaging, and those things allow us to capture a lot more detail of the flows around buildings. And with that kind of information, we can create both better models for the aerodynamic loading. It's really helpful for people seeing what those flow patterns are, finding mitigation things, and knowing more details about the flow field has really helped us with that. Well, it's wonderful. It's, recognition from your peers is interesting. I've had awards, international awards, and in wind engineering it's specific to the discipline, but winning this award that goes across the disciplines of everyone practicing in our great province, it really means a lot to me.
for his work increasing the understanding of tornado occurrence and intensity across Canada. Gregory Kopp is a worthy recipient of the Engineering Medal in the Research and Development category.